Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the frequency trees practice questions. If you need any extra help on frequency trees, if you go to corbettmaths.com/content, so you scroll down to video 376, there's a dedicated video tutorial there on frequency trees. In this video, we're going to focus on the solutions to the practice questions, so let's get started. So here we've got our first question, and we're told over 1 week, 40 patients visit a dentist. So a dentist has 40 patients over 1 week. The frequency tree shows some information. So we've got some information in this frequency tree, and we've been asked to complete the frequency tree. Okay, so we've got 40 patients altogether. 23 have morning appointments and the rest have evening appointments. So if we take our 23 away from 40, we can see how many patients have evening appointments. So if we do 40, take away 23, that's equal to 17. So that means that 17 patients have evening appointments. Now let's look at the patients that have morning appointments. So there's 23 of those altogether and 21 of those patients are on time. So the rest of them were late. So if there's 23 altogether and 21 are on time, that means 2 must be late, because 23 take away 21 is equal to 2. And finally, in terms of the evening appointments, there's 17 patients that have got evening appointments and 5 of those were late and the rest were on time. So if we take our 5 away from 17, we can see how many were on time. So 17 take away 5 is equal to 12. So that means that 12 of those patients were on time. And that's it. And that's it. So that's question 1. So we've filled out the missing numbers in that frequency tree. Okay, let's have a look at our next question. So next question says 124 people took part in a talent show. So there's a talent show. Each person either sang or danced. So some of the people sang and the rest danced. And 76 of them were singers, 14 made it through to the final and the rest were eliminated, and 6 dancers made it through to the final. Complete the frequency tree. So we've got this frequency tree. We're told there's 124 people together and that some danced and some sang. And if we have a look at the question, we're told that 76 are singers. So that means that 76 of them are singers and the rest of them must have danced. So if we take away the 76 away from the 124, we can see how many people danced. So 124 take away 76, so let's do that and see what we get. 6 take away 4, well, let's borrow, so that's going to be 1 and now 14. 14 take away 6 is equal to 8. 1 take away 7 we can't do, so let's borrow again. So we've got 11 take away 7, which is equal to 4. So that means that there's 76 singers and there's 48 dancers. Now in terms of the final and eliminated, some of the 48 made it through to the final and the rest were eliminated. And same thing for the singers, some of them made it through to the final and some were eliminated. Now we're told that 14 people made it through to the final. So that means that if we add together this number and this number, we'll get 14. And we're told that 6 dancers made it through to the final. So if we go to the dancers, 6 of those went through to the final and the rest were eliminated. Now if there's 48 of them, if we do 48 take away 6, that's equal to 42. So that means that 42 of the dancers were eliminated. Okay, now let's have a look at the singers. So the 76 of them, and some of them made it through to the final and some were eliminated. Now we're told that 14 people made it through to the final. Now we know that 6 dancers made it through to the final, so if we do 14 take away 6, that's equal to 8. That means that 8 singers made it through to the final because 6 plus 8 is equal to 14. And now that we know that 8 of the singers made it through to the final, to work out how many were eliminated, if we do 76 take away 8, that's equal to 68. So that means there must have been 68 singers that were eliminated. And that's it, that's our frequency tree. Okay, let's have a look at question number 3. So question number 3 says a group of 80 boys and girls sat a test. So 80 boys and girls sat a test. 36 of the children are girls, so 36 of them are girls and the rest of them are boys because we know it's a group of 80 boys and girls. So 80 take away 36 is equal to 44. So that means there's 44 boys. We're told that 9 of the 80 children failed the test, so 9 of them failed the test, and 39 boys passed the test. So if we go to the boys, 39 of them passed the test. Now if we do 44 take away 39, that'll tell us how many boys failed the test. So 44 take away 39 is equal to 5. So that means that 5 boys failed the test. So we know that 5 boys failed the test. Now we're told that 9 of the 80 children failed the test. So that means that 4 girls failed the test. And then finally, because there was 36 girls, if we take away 4, that tells us how many girls passed. 36 take away 4 is equal to 32. So 32 girls passed the test. And that's it. Okay, then let's have a look at part B. Part B says one of the boys is chosen at random. So if we go back up, there's 44 boys. And we're asked to work out the probability that the boy failed the test. So out of the 44 boys, 5 of them failed the test. So that means the probability of the boy failing will be 5 out of 44. And that's it, 5/44. Okay, let's have a look at our next question. Right, so question number 4 says, shown below is a frequency tree that shows some information about the types of sandwich at a buffet. And we've got 300 sandwiches all together. 165 are tuna sandwiches and the rest are cheese sandwiches, and some of them are on white bread and some of them are on brown bread. So you've got tuna on white bread, tuna on brown bread, cheese on white bread and cheese on brown bread. We're asked to complete the frequency tree. So let's start off by finding out how many sandwiches were cheese sandwiches. So altogether there were 300. So if we take away 165, how many tuna sandwiches there were, that tells us how many cheese sandwiches there were. So 300 take away 165 is equal to 135. So that means there's 135 cheese sandwiches. Now let's work out how many tuna sandwiches were on brown bread. So altogether there were 165 tuna sandwiches and 44 of them were on white bread. So if we take away the 48 from 165, that tells us how many tuna sandwiches were on brown bread. So 165 take away 48, that's equal to 117. So there's 117 tuna sandwiches on brown bread. And then finally, in terms of the cheese sandwiches, out of the 135 cheese sandwiches, 74 were on white bread and the rest were on brown bread. So if we take 74 away from 135, that tells us how many cheese sandwiches were on brown bread. So 135 take away 74 is equal to 61. So that means there's 61 cheese sandwiches on brown bread. And that's part A. Part B. Part B says Orla picks a sandwich at random, so she's going to pick a sandwich at random, so any of the 300 sandwiches. And we're asked to find the probability that the sandwich that she has picked was made out of brown bread. So there's 300 sandwiches altogether, so she's picking out one out of the 300 sandwiches. And we're asked to find the probability that the sandwich was made on brown bread. So we want to find out how many brown bread sandwiches there were. So if we have a look here, we've got 117 tuna sandwiches on brown bread, and we've got 61 cheese sandwiches on brown bread. So if we add together 117 and 61, that'll tell us how many sandwiches were on brown bread altogether. So we do 117 plus 61 is equal to 178. So that means that 178 of the sandwiches were on brown bread. So Orla picks one of the sandwiches, one of the 300 sandwiches, and we want to find the probability that the sandwich was made out of brown bread. That's going to be 178 out of 300. Now we can leave it like that if we wanted to, or we can cancel it down, and if we cancel it down we get that's equal to 89 out of 150, and that's it. So that's 89 out of 150. Okay, let's have a look at our next question. Okay, let's have a look at question number 5. So question number 5 says 58 people work for a company and they either travel to work by bus or by car. And we're told that 14 of the people so there's 58 of them, so let's put that in there actually to begin with, 58. And then we're told that 14 of the 20 people that travelled by a bus, so the 14 of the 20 people that travelled by bus were on time. So there's 20 that travelled by bus and 14 of them were on time. And that means that 6 of them were late. So we've actually filled out all of those. And also we're told that 3 people who travelled by car were late. So if we go down, we know that 3 people that travelled by car were late. Now there's 58 people and 20 travel by bus. That means that the rest of them, 38 of them, because 58 take away 20 is equal to 38. 38 of them travel by car. 3 of them were late, so that means that the rest of them, the 35 of them, were on time. And that's it. So we filled out our frequency tree. And part B says one of the people are picked at random. Work out the probability that this person travelled by car and was on time. So there's 58 people altogether, so it's going to be out of 58. And we're asked to find the probability that this person travelled by car and was on time. So altogether there was 35 people that travelled by car and were on time. So it's going to be 35 out of 58. And that's our answer, 35 58ths. Okay, let's have a look at our next question. Question number 6. Okay, let's have a look at question number 6. So question number 6 says 160 people sit the driving test. 108 of them took 10 or more hours of driving lessons. 29 of the people who took 10 or more hours of driving lessons failed the driving test. And 104 people passed the driving test altogether. Use this information to complete the frequency tree. So let's look at our frequency tree. We know that 108 people took 10 hours or more. So that means there's 108 people in here. And that means that less than 10 hours of driving lessons would have been the rest of them. So 160 take away 108 is equal to 52. So that means that 52 people took less than 10 hours. Now we're told that 29 of the people who took 10 or more hours failed the driving test. So out of these people, 29 of them failed. That means that the rest passed. So if we do 108 take away 29, that's equal to 79. So that means that 79 of the people who took 10 or more hours passed the driving test. And then finally, we're told that altogether 104 people passed the driving test. So we know that 79 people passed that took 10 or more hours. So to work out the rest of the people that passed, so if we do 104 take away 79, that's going to tell us how many people go here, how many people took less than 10 hours of driving lessons and passed the driving test. And that's going to be equal to 25. So that means that 25 people go there, and it means that the rest of them failed. So if we do 52 take away 25, that's equal to 27. So that means that 27 of the people who took less than 10 hours of driving lessons failed their test. And that's it. Okay, and part B. Part B says one of the people who took less than 10 hours of driving lessons, so one of these people, is picked at random. So it's going to be out of these 52 people, they're picked at random, find the probability that this person passed the driving test. So because it's one of the people who took less than 10 hours of driving lessons, it's going to be out of 52. And 25 of them passed the driving test, so it's going to be 25 out of 52, or 25, 52, 50 seconds. And that's it. So 25 out of 52. Okay, let's have a look at our next question. Okay, question number 7 says, in a secondary school, there's 533 students altogether in year 7 and 8. And there's 255 students in year 8. So there's 255 students in year 8. And actually, let's work out how many year 7s there were, because if we do 533, take away 255, and it's a calculator question, that's nice, we can work out how many year 7s there were. So 533 take away 255 is equal to 278. So there's 278 year 7s. Now we're told that the PE department runs football training after school on a Thursday for year 7 and 8 students. And 85 of the 165 students that attended the football session are in year 7. So out of the year 7 students, we know that 85 of them attended. So 85 of them attended. And that altogether 165 students attended the football session. So if we take that 85 away from 165, so 165 take away 85, that's equal to 80. That means that 80 year 8s attended the football training. Okay, because 165 students attended the football training, and that 85 of them were in year 7, so that means that the rest must have been in year 8, so we know that that's 85 and that's 80. And then finally, let's work out these two missing numbers here and here by taking away the 85 away from 278 and the 80 away from 255. So let's do that. 278 take away 85, so 278 take away 85 is equal to 193, and here that's 193, and here for the years it didn't attend, if we do 255 take away 80, that's equal to 255 take away 80 is equal to 175. So that means that 175 year 8 students didn't attend. And that's it, so we've completed the frequency tree. And part B says, Mr. Edwards says a greater percentage of the year 7 students attended football training than the year 8 students. Explain why Mr. Edwards is wrong. So let's have a look at this. He's saying a greater percentage of these students attended than the percentage of year 8 students that attended. So let's work out those student numbers as percentages. So let's work out what percentage of year 7 students attended football training. So we've got 85 out of 278. So let's write that down. Year 7 is 85 out of 278. That's a fraction. We want to change that to a decimal first of all. So using our calculator, we can divide the numerator by the denominator. So 85 divided by 278 is equal to 0.305755 and so on. Now we want this as a percentage, that's a decimal, so let's times it by 100 and we'll get 30.5755 and so on percent. Well, let's just round it to 2 decimal places. That'll be 30.58% to 2 decimal places. Now let's look at the year 8 students. Year 8. So altogether in year 8 there were 255 students and 80 attended. So we want to write that as a fraction, 80 out of 255. Let's write it as a decimal. 80 divided by 255 is equal to 0.313725 and so on. That's a decimal. Let's change it to a percentage. So let's multiply by 100. That's going to be 31.3725 and so on percent. And let's just round it to 2 decimal places. So that'll be 31.37% to 2 decimal places. As you can see, 30.58% of the year 7s attended, whereas 31.37% of the year 8s attended. So Mr. Edwards said a greater percentage of year 7 than year 8s attended. That's not true. Actually, a greater percentage of year 8s attended. So let's write that down. And that's it. So a greater percentage of year 8 students attended. Okay, let's have a look at our next question. Okay, question number 8. So question number 8 says, Corinne asks 300 people if they're more likely to vote for the purple party or the yellow party. And 195 people were 50 years or over, and the rest were under 50 years old. And 2/3 of the people under 50 said they would vote for the purple party, and 3/5 of the people that are 50 years and over would vote for the yellow party. And the question says, which party did most people say they're most likely to vote for? So let's complete our frequency tree, and that's going to help us. So we know there's 300 people altogether, and if we go up, we're told that 195 of them were 50 years and older. So if we go to 50 years and older, we know 195 of them are 50 years and older, and the rest are under 50. So if we do 300, take away 195, that's equal to 105. So that means there's 105 people under 50, and there's 195 people 50 or over. And now we need to find out how many of each of these categories, the under 50s and the 50 and over, voted for either the purple party or the yellow party. So we go purple party, yellow party, purple party, yellow party. So we're told that 2/3 of the people under 30, so 2/3 of these people would vote for the purple party. So if we work out 2/3 of this number, that's how many would vote for the purple party. So let's work out 2/3 of 105. So to get 2/3 of 105, we're going to need to divide it by 3 to get 1/3. So 105 divided by 3. So 3 into 1 doesn't go, remainder 1. 3 into 10 goes 3 times, remainder 1. And 3 into 15 goes 5 times. So 1/3 of 105 is 35. Now if we times that by 2, we will get 2/3. So 35 times 2 is equal to 70. So 70 people under 50 would vote for the purple party. In terms of the yellow party, well, that's going to be the rest of the 105 people. So 105 minus 70 is equal to 35. So that means that 35 people under 50 would vote for the yellow party. Okay, now let's have a look at the people that are 50 or over. Well, 3/5 of them would vote for the yellow party. So 3/5 of these people, 3/5 of this number would vote for the yellow party. So we need to work out 3/5 of 195. So let's get a fifth to begin with by dividing by 5. Remember, divide by the bottom, times by the top. So 195 divided by 5. So 5 into 1 doesn't go, so 0, remainder 1. 5 into 19, well, that would be 3, remainder 4. And 5 into 45 goes 9 times. So a fifth of 195 is 39, but we want to find 3/5, so we're going to multiply this by 3. So 39 multiplied by 3. So 3 times 9 is 27, put our 7 down, carry our 2. And 3 times 3 is 9, plus 2 is 11. So 117 people that are over 50 or 50 or over would vote for the yellow party, so 117. That means the rest would vote for the purple party, so 195 take away 117 is equal to 78. So that means that there's 78 people who are 50 or over who would vote for the purple party. Now the question says, which party did most people say they're most likely to vote for? So we need to work out how many people in total wanted to vote for the purple party. So we're going to add together the 70 and the 78. And then we're going to see how many people would vote for the yellow party. So we'll add together the 35 and the 117, and we'll see which one of those numbers is bigger. So let's do the purple party. So purple. So that's going to be 70 plus 78, which is equal to 148. And in terms of the yellow party, that's 35 plus 117, and that's equal to 152. So as you can see, more people would vote for the yellow party than the purple party, so that's our answer, the yellow party. And that's it. Okay, let's have a look at our next question. So question number 9. Question number 9 says there's 80 students in year 11, and the students are either in class A or class B. So the students in year 7 are either in class A or class B, and all 80 students take part in one activity during their PE lessons. And then we're told some information that 39 of the 80 students are in class A. The same number of students play cricket as hockey, so altogether the same number play cricket as hockey. 11 of the 18 students that play tennis are from class B, and that 3 more class A students than class B students play cricket. So let's have a look at this diagram and see what we can fill in. Okay, so to begin with, we're told that 39 of the 80 students are in class A. So that means that this number plus this number plus this number would add together to be 39, because we know there's 39 students in class A altogether. That means if we add those, we get 39. We're told the same number of students play cricket as hockey, so the same number of students play cricket as hockey, so that means that these two numbers are the same. And we're told that 11 of the 18 students playing tennis. Oh, so there's 18 students playing tennis. So 18 students are playing tennis, and 11 of them are in class B. So there's 11 in class B, and that means there must be 7 in class A, because obviously they would add together to be 18. Now actually here we're told there's the same number of students playing cricket as hockey. Now there's 80 altogether, so if we do 80 and we take away our 18, that would be equal to 62. And then if we divide that by 2, we can then find out how many people are playing cricket and hockey. So 62 divided by 2 is equal to 31. So it means there's 31 students playing cricket and there's 31 students playing hockey. Next, we're told that 3 more Class A students and Class B students play cricket. So if we have a look at our cricket, our 31 students playing cricket, we know that there's 3 more from Class A than there is from Class B. So in other words, this number is 3 greater than that number. Actually, so if we call this one X and this one X plus 3, because because this number is 3 greater than that number, they will add together to be 31. So let's write an equation there. X plus 3 plus x is equal to 31. And if we solve this equation, we can find out what x is, the number of students from class B. So if we do x plus x, that's 2x, and we've still got our plus 3, and that's equal to 31. If we take away 3 from both sides, we get 2x equals 28. And if we divide by 2 and divide by 2, we get that x is equal to 14. So that means there's 14 students from class B that play cricket, and 3 more in class A, so that's going to be 14 plus 3 is 17. And if we check that, 17 plus 14 is 31, and the number of students from class A is 3 greater than the number of students from class B. Now you can do that without using an equation. You could have actually just sort of figured it out and sort of tried 16 and 15, well that's only 1 more, and then you could try 17 and 14, well that's 3 more, so that's perfect. So that's the number of students from class A and class B that do cricket. And finally, we need to find out the number of Class A students and Class B students that are playing hockey. So there's 31 students playing hockey. Now, if we go back to the question, the very first sentence says 39 of the 80 students are from Class A. So if we have a look at Class A, we've got 7 here from Class A here. So this circle, this oval or whatever. So we've got 7 here from Class A. We've got 17 here from Class A. And then this number here is Class A. And if we add them together, we should get 39. So that means that we can figure out this number here, because we can do 7 plus 17. That's equal to 24. There's 39 students altogether in Class A. So 39 take away 24 is equal to 15. So that means that must be equal to 15. And because 15 plus 16 is equal to 31, that must mean there's a 16 there. And that's it. And part B says, what fraction of Class A play cricket? So remember in the question we're told there's 39 students in Class A. So that means that the denominator of our fraction will be 39, because 39 Class A students. Because it says, what fraction of Class A play cricket? So there's 39 altogether in Class A. And let's have a look at cricket. Class A cricket, the 17 play cricket. So the fraction of the fraction of Class A that play cricket will be 17 39ths. So that's our answer, 17 39ths. Okay, question number 10, and this is a calculator question. On a Saturday evening, 390 people watched movies in a cinema. So in a cinema, there's 390 people that visit the cinema. And we're told that a standard movie ticket costs £7 and a 3D movie ticket costs £9. So the ones where you wear those 3D glasses. And some of the customers also have vouchers that entitle them to 10% off the ticket price. So there perhaps is a promotion, whether they have this particular voucher, they get 10% off the price. So instead of paying £7, they'll be paying 10% less. So 10% of £7 would be 70p. So that would be 70p less. That'll be £6.30 for those customers if they went to see a standard movie ticket with the 10% voucher, 10% off voucher. And the customers that went to see the 3D movie and they had the voucher, well, that's 10% off. 10% of £9 is 90p. And if you take that away, you get £8 10p. So they will be the prices if they have the voucher. And then we're told that 110 customers bought tickets for 3D movies. So 110 customers bought tickets for 3D movies. And that means the rest, the 280, must have went to see standard movies. And we're told that 84 customers used the voucher. So altogether, 84 customers used the voucher. So this number plus this number would be 84. So out of these 280 customers, 237 of them did not use a voucher. So 237 of those did not use a voucher. So if we do 280 take away 237, that's equal to 43. So that means that 43 of those people that went to see standard movies used a voucher and they got 10% off the price. And then in terms of the customers that went to see 3D movies, well, we know altogether 84 used a voucher. So if we do 84 take away 43, that's equal to 41. So that means that 41 of these customers used a voucher, and that means the rest didn't. So if we do 110 take away 41, that would tell us how many people went to see 3D movies without a voucher, and that's equal to 69. And that's it. So we've completed the frequency tree. And the question says, how much money did the cinema make that evening through ticket sales? So we need to find out how much money the cinema made that evening through ticket sales. So let's start off by writing down how much people paid for their tickets. So for instance, these people that went to see a 3D movie with a voucher. So remember, they paid 10% less. So because they paid 10% less, they paid £8 10p, because obviously 10% of £9 is 90p. And then if we take that away, that leaves you with £8 10p. So they paid £8 10p each. The people that went to see a 3D movie without a voucher, they paid £9. So these people paid £9 each. The people that went to see the standard movie with a voucher, well, the normal movie is £7. The voucher's 10% off, so that's 70p off, so that's £6.30. So they paid £6.30 each, these people. And the people went to see a standard movie without a voucher paid £7 each. So we now know that 41 people paid £8.10p each, 69 people paid £9 each, 43 people paid £6.30 each, and 237 people paid £7 each. So if we do 41 times this, 69 times this, 43 times this, and 237 times this, and then add them all up, that would tell us a total amount of money that the cinema received in ticket sales. So let's work that out. We've got 41 multiplied by £8.10p. We've got 69 multiplied by 9. We've got 43 multiplied by £6.30. And we've got 237 multiplied by £7. So let's work out how much each of those is, and then let's add them all up. So these people pay a total of £332 and 10p. These people pay a total of £621. These people pay a total of 270 and 90p. And then finally, these people pay a total of £1,659. And then if we add them all up, we get the grand total. And that's equal to £2,883. And that's it. Okay, let's have a look at our next question. So question number 11 says 140 students sign up to a college course, and at the end of the course each student has 2 attempts to pass the test. So they've given the first attempt. If they pass it, fantastic, and if they don't pass it, they get one more shot at passing that test, and if they pass the test at either attempt, they get a certificate. And we're told that 85% of the students receive a certificate, and we're asked to work out how many of the students pass the test in their second attempt. Well, first of all, we have a look here. We've got 140 students and 68 pass in the first attempt. So if we do 140 take away 68, that would tell us how many students failed. So 140 minus 68 is equal to 72. So that means that 72 students failed on their first attempt. So it's quite a difficult test. So only 68 passed in the first attempt and 72 failed. Now, we're told that 85% of the students receive a certificate. So that means that this number plus this number must be 85% of the students. So if we work out what 85% of 140 is, that would tell us how many students pass the test altogether. And that means we can then work out this missing number here. This is quite nice. This is a calculator question. So we're going to take our 140, because there's 140 students. We're going to divide that by 100 to find 1%. So it's going to be 1.4. And then we're going to multiply that by 85. And that will tell us our 85%. So 1.4 times 85 is equal to 119. So altogether, 119 people get a certificate. Now, if we go back up, we know that 119 people get a certificate, and so that's the number of people that pass the course. So we've got 68 passing the first attempt, so if we do 119, take away 68, that would tell us how many students pass on their second attempt, and that's what we've been asked to find. So 119 take away 68 is equal to 51. So that means that 51 pass, and out of interest, that means that 21 fail, because obviously they need to add together to be 72. So the question says, how many students passed on their second attempt? The answer is 51. So the answer is 51, and that's it. Okay, question number 12. So question number 12 says, Barry runs a game at a school fair, and players can either try and roll a 6 on a dice, or they can try and hit a bullseye with a dart. And each player pays some money to play the game, and they can either choose to roll the dice or throw the dart. And if they roll a 6 on the dice, they win £2. And if a player hits the bullseye, they win £5. And we've got a frequency tree here, and altogether we're told that Barry makes £145 profit from the game, and we're asked how much does it cost to play Barry's game. So let's have a look at our frequency tree. So the game is played 500 times, and on 80 occasions people throw the dart, so that means that 420 roll the dice, and we're told that 350 lose whenever they roll the dice. That means if we do 420 take away 350, that's equal to 70 people win. So 70 people win £2. Now, in terms of throwing the darts, well, on 80 occasions they choose to throw the dart, and on 3 occasions they hit the bullseye and win the £5. And that means on 77 occasions they don't win. So that means that 77 is going to go here. So let's find out how much money Barry gives out in prizes. So on 70 occasions he gives out £2. So that's 70 multiplied by £2. That's equal to £140. So for the people that rolled the dice, he had to give out £140 in prizes. And in terms of the darts, it's only won 3 times, and each time it's won they win £5. So it's going to be 3 multiplied by £5 is equal to £15. So altogether that means that Barry gives out £155 in prizes, because he gives out £2 70 times and he gives out £5 3 times. So if we do 140 plus £15, that's equal to £155 in prizes. Now we're told that altogether Barry makes £145 profit from the game. So that means that after he's given out the prizes, after he gives out this £155, he's left with £145. So that means that if we add together the profit and how much money he gives out in prizes, that would tell us how much money Barry took in from people playing the game. So if we do 145 plus 155, that's equal to £300. So that means that Barry collected £300 from the people playing the game. Now we're told that the game is played 500 times. So if we divide our £300 by the 500 times the game is played, that would tell us how much it costs to play the game once. So if we do £300 divided by 500, because it's played 500 times, that would tell us how much it costs to play the game. So 300 divided by 500 is equal to 0.6 or £0.6 or 60p. So the game costs 60p to play, and that's it. Okay, let's have a look at question number 13. So question number 13, we've got quite a lot of information here. We're told that in a college there's 240 year 10 and 11 students, and they all study one language, so either French, German or Spanish. And 40 more students study French than Spanish, and twice as many students study German than Spanish. Actually, that's a bit of information that we can actually now work out how many people study French, German and Spanish, because we can actually make equations here. We're told that 40 more students study French than Spanish and twice as many students study German than Spanish. So if we call the number of students who study Spanish X, German, well, that's twice as many, that would be 2x. And French, that's 40 more students study French than Spanish. Well, if Spanish is X, French will be 40 more, so that's going to be X plus 40. So we know that if there's X number of students studying Spanish, German will be 2x and French will be X plus 40. And now we're told that that's equal to 240 students, so we can make an equation. If we add together our X plus 40, our 2x and our X, we can add that all up and then we can solve that equation and we can find out what X is, and that will mean that we know how many students study Spanish, and then we can work out how many study French and German. So let's do that. So let's add this algebra together. So we've got X plus 2x plus X, well that'll be 4x's, and then we've got plus 40, and that's equal to 240. Now let's solve our equation. So we want the X on its own, so we want to get rid of this plus 40, and then we want to get rid of this multiplied by 4. So let's take away 40 and take away 40. And on our left hand side we had 4x plus 40. We're taking away the 40, so it's just going to leave us with 4x. And on the right hand side of the equation we had 240, take away 40, that's going to be equal to 200. Now 4 times the number is 200, so let's divide by 4 and divide by 4. And then 4x divided by 4, well that'd be 1x or X, and on the right hand side we've got 200 divided by 4, that's equal to 50. So that means there's 50 students studying Spanish, there's twice as many studying German, so it's going to be double that, which is 100, and there's 40 more study French than Spanish, so 50 plus 40 is equal to 90. So that means there's 90 studying French, 100 studying German, and 50 studying Spanish. And let's just check it. 100 plus 90 is 190, plus 50 is 240. Fantastic. Okay, now let's have a look at our next lot of sentences. We're told that twice as many year 10 students study French than year 11 students. So we're looking for two numbers to add together to be 90. Well, one's twice as big as the other. Well, that's going to be 60 for the year 10 students and 30 for the year 11 students, because the number of year 10 students is twice as big as the number for year 11 students, and they add together to be 90. Or you could have treated it as x and 2x, and then they add together to be 3x and solve it, and you'd get 30 and 60 for the number of year 10 students and the number of year 11 students. So there's twice as many year 10 students studying French than year 11 students. Okay, next. We're now told that 60% of the students studying Spanish, so 60% of this number are in year 11. So we need to work out 60% of 50. So let's get 10% of 50. So 10% would be equal to 5. If we then multiply that by 6, we get 60%. So 60% and multiply by 6, that would be equal to 30. So that means there's 30 students that are studying Spanish in year 11. So that means that there's 30 students studying Spanish in year 11, 60% of this number. That means the remainder, the 20, would be in year 10. And then finally, 3/4 of the students studying German are in year 11. So we want to work out 3/4 of this number. So to get 3/4, we divide by the bottom. So 100 divided by 4, 3/4 will be 100 divided by 4, which is 25, times by 3 would be 75. So the 75 year 11 students studying German, and the rest, a quarter, would be 25 year 10 students. And the question says, how many students are there in year 10? Well, it's going to be 60 plus 25 plus 20. So if we do 60 plus 25 plus 20, that will be equal to 105. So that means there's 105 year 10 students. And that's it. Question number 14. Bag A and bag B contain red, green and blue marbles. And altogether there's 552 marbles. So in bag A and bag B, altogether there's 552 marbles. And the pie chart shows information about the marbles in each bag. So we've got some information. So in bag A, for instance, we know a quarter of them are red because it's a right angle. So that's a quarter. So a quarter of them are red. We know that 120 degrees is green. That's a third of them, because a third of a full circle is 120 degrees. So a third of the marbles in bag A would be green, and the rest of them would be blue. And then in terms of the marbles in bag B, we know that 3/4 of them, because 270 degrees is 3/4, so 3/4 of them are green. And then in terms of the rest, we've got 60 degrees, that's a sixth of a full circle, and that means a sixth of them are red and the rest are blue. Okay, and we're told the number of marbles in bag A to the number of marbles in bag B is 3 to 20. Complete the frequency tree. Okay, so we've got this frequency tree and we need to complete it. Now we know altogether there's 552 marbles, so there's 552. And in terms of bag A and bag B, they're in the ratio 3 to 20. So if we add together the numbers in the ratio, 3 plus 20 is equal to 23. And if we divide the total by 23 and then times it by 3 and by 20, we can find out how many marbles are in bag A and how many marbles are in bag B. So 552 divided by 23, and this is a calculator question, is it? Yep. So that would be equal to 552 divided by 23 is equal to 24. So that means there's 24 in one part. So if we do 3 times 24, that's equal to 72. That means there's 72 in bag A. And then if we do 20 times 24, that's equal to 480. So that means there's 480 marbles in bag B. And that's it. So, and if we add those together, we get 552, which is great. So let's write those in our frequency tree. So this is going to be 72 in bag A, and there's 480 in bag B. Okay, so we've now got those numbers in our frequency tree. Now we're going to look at our pie charts to work out how many red, green and blue, and red, green and blue there are in each of the bags. So let's start off with bag A. So we go up to bag A. First of all, the red, that's a quarter. It's a right angle, so we're going to work out a quarter of this number. So a quarter of 72. So if we do 72 divided by 4, that would tell us how many red marbles there are. So to divide by 4, half it and half it again. Half it would be equal to 36, and half it again would be 18. So that means there's 18 red marbles in that bag. Okay, next, let's go back up. Green. Green is 120 degrees. Well, 120 out of 360. If we cancel that down, we would get 12 out of 36. And divide both of those by 12, we get 1 over 3, or a third. And if you think about it, 120 degrees plus 120 degrees plus 120 degrees is 360 degrees. So that means that a third of the marbles are green. So if we divide 72 by 3, we'll find out how many green marbles there are. So 72 divided by 3 is equal to, well, 72 divided by 3. 3 into 7 goes 2, remainder 1, and 3 into 12 goes 4 times. So that means that 24 of them are green. And in terms of the blue, well, if we just add together the red and the green and take that away from 72, that'll tell us how many blue marbles there are. So 18 plus 24 is equal to 42, and 72 take away 42 is equal to 30. So that means there's 30 blue marbles in bag A. So we've done bag A, now let's have a look at bag B. So bag B, we've got our red, green and blue. Let's look at, where there's 480 marbles altogether. So let's go up to our pie chart. Now the first thing that I'm spotting is this 270 degrees, because if this is 270 degrees, that means the rest of it is 90 degrees. So that's a quarter for blue and red. So it means the rest, the 270 degrees, is 3/4 of the full circle. And we can actually just show this. 270 out of 360 divided by 10 is 27/36, and dividing both of those by 9, we get 3/4. So that means that the 3/4 of the marbles in bag B are green. So we need to work out 3/4 of 480. So 480 divided by 4 would be 120, and 120 multiplied by 3 is equal to 360. So that means there's 360 green marbles in bag B. Let's just check it was green. Yep, green. Okay, now let's go back up here. Now in terms of our blue and our red, well, red, let's work out what fractions these are. Red. would be 60 out of 360. And if we divide both of those by 10, we get 6 out of 36. And we can divide both of those by 6 to get 6 divided by 6 is 1, and 36 divided by 6 is 6. So that means that a sixth of the marbles in bag B are red. And in terms of blue, if we wanted to work out blue, we would do blue is 30. So that's 30 degrees out of 360. Dividing both of those by 10 would be 3 out of 36. And dividing both of those by 3 would give me 1/12. So a 12th of the marbles are blue and a 6th of the marbles are red. Well, let's work out how many red there are, and then the rest would be blue. So let's go down. We've got red. So we've got 480, and we want to get a 6th of that because a 6th of the marbles are red. So if we do 480 divided by 6, that would tell us how many red marbles there are. So 48 divided by 6 is equal to 8. So 480 divided by 6 would be equal to 80. So that means there's 80 red marbles, and the rest must be blue. Well, let's add these up. Well, 80 plus 360 is equal to 440. And the rest, well, there's 480, so 480 minus 440 is equal to 40. So that means there's 40 blue marbles. And that's it. So these have been the video solutions to the frequency tree practice questions. I really hope you found this useful. If you have found it useful, please like the video and please subscribe to the YouTube channel. If you need any extra help on frequency trees, feel free to go to corbettmaths.com/contents and scroll down to video number 376, and that's a video tutorial on frequency trees. Also in this video, we've done some work on percentages and fractions of amounts and so on, ratios as well. So there's those other videos on Corbettmaths that might be quite useful as well, solving equations. So feel free to watch those. But again, I really hope you found this video useful, and all the very best of luck with your studies. Cheers. Bye-bye.